Good morning. In this video, we are going to see the solved gate questions under the topic crypto system and digital signature. So in this video, I have covered 5 questions that I have asked previously in the gate question papers in computer networks under the topic crypto system and digital signature. So before going to this video, it is better if you have some recap on the topic, and please do a recap and listen the video. It will be useful. Let's go to the video. So question number 1, it is asked in the year 2019. The question is, a sender S sends a message M to receiver R, which is digitally signed by S with its private key. In this scenario, one or more of the following security violations can take place. So here sender S is sending message to the receiver R, the message is M, and it is digitally signed using the sender's private key. And so which of the following are possible security violations which can happen? The violations are: S can launch a birthday attack to replace M with a fraudulent message. A third party attacker can launch a birthday attack to replace M with a fraudulent message. R can launch a birthday attack to replace M with a fraudulent message. So in all these 3 options, they are talking about birthday attack. What is birthday attack? How it can happen? Here, yes, sender is sending the message M, digitally signed with their private key, to the receiver R. And in the violations, all are talking about birthday attack. What is birthday attack? So, birthday attack happens, that is, if someone send a fraudulent message that can be generated with the same hash value and the same digital signature as of the original message sent by the sender, is called the birthday attack. So the fraudulent message with the same hash value, so that the receiver can decrypt the message easily, and with the same digital signature as of sender, so that the receiver cannot can decode the can verify the digital signature and believe that it is sent by the sender. So if that type of message is sent by some third party or somebody to the receiver, it means it is a birthday attack. So let's analyze the options one by one. S can launch a birthday attack to replace M with a fraudulent message. Is it possible? Yes, it can be possible, because the sender will have its private key, and the sender will know what the receiver will have the public key to decode the message. So there is a possibility of sending a fraudulent message with the same digital signature as the sender have the private key and the public key, so that the receiver can decode everything without any that believing that the sender is sending the message. So there is a possibility of having a birthday attack, doing a birthday attack by the sender itself to the receiver. Next option. A third party attacker can launch a birthday attack to replace M with a fraudulent message. Is this possible? No, because a third party will not have any private key to decode the message and the digital signature. So obviously he cannot send a fraudulent message using the same digital signature as of the sender. So a third party cannot launch a birthday attack. And R, here R is the receiver. R can launch a birthday attack to replace M with a fraudulent message. No, this is same as the third party. R will not have any private key. It will have only the public key to decrypt the message. So R also cannot launch a birthday attack. So the only option is the sender can send a fraudulent message. So the sender can launch a birthday attack. So the answer is option B, 1 only. That is, S can launch a birthday attack to replace the M with a fraudulent message. Next question. Anarkali digitally signs a message and sends it to Salim. Verification of the signature by Salim requires Anarkali's public key, Salim's public key, Salim's private key, Anarkali's private key. This question is asked in the year 2016. So the question is, Anarkali is sending a message to Salim with a digital signature using a private key of Anarkali. So in a cryptography system, the receiver will require the sender's public key to verify the digital signature, and to decrypt the message. We'll have the private key to decrypt the message, and we'll need the sender's public key to verify the digital signature of the sender. So here Anarkali is sending the digital signature with private key. So Salim requires the public key of Anarkali to verify the digital signature and a private key to decrypt the message. So here verification of signature requires Anarkali's public key, sender's public key, that is Anarkali's public key. So answer is option A. This is a simple question. And let's move to third question. Suppose that everyone in a group of n people wants to communicate secretly with n-1 others using symmetric key cryptographic system. The communication between any two persons should not be decodable by the others in that group. So the number of keys required in the system as a whole to satisfy the confidentiality requirement is. So here the group have n people. Each one in that group is communicating with each other with different keys. See, take for example, this is the graph using symmetric key cryptographic system. So it will be a complete graph, and each node is the people. They are communicating with each other with different keys. This node and this node communicating with each other with different keys. So let us consider it as a complete graph having number of, so it is a complete graph. Each node is the people and they are communicating with each other with different keys. So the number of keys required might be the number of edges needed in this complete graph with n vertices. Here n people, so n vertices. So the answer is obviously n into n minus 1 by 2 if we are well known with the theory part. For our deep analysis, I can explain like n, here this group have n people. So they have to communicate with other n-1 people with different keys. For each people they will have one key, another one another key, another one another key. So it will be like 1 plus 2 plus 3 till n-1 plus n-2 plus n-1. So on solving this one we will have n into n-1 by 2. In simple we can say it is a complete graph. So the number of keys will be the number of edges needed in a complete graph with n vertices, that is n into n-1 by 2. As it is using symmetric key cryptographic system, obviously it will have each access of the keys with both parties will be different. So each one will have different keys with to communicate with each other people. So the answer is n into n-1 by 2. I wrongly highlighted this one. The answer is option C. Next question. Using public key cryptography, X adds a digital signature sigma to its message M, encrypts it and send it to Y, where it is decrypted. So X is sending a message M, encrypts it and with a digital signature sigma, and then it is sent to Y. Y decrypts that message and verify the digital signature. So which one of the following sequence of keys is used for operations? We have to find. Here they are using public key cryptography. So X is sending the message and digital signature in the encryption form, and Y have to decrypt the message and verify the digital signature. Here they are using public key cryptography method. So usually in a public key cryptography method, the sender will have a private key for the digital signature and encrypt the message with the receiver's public key. So here X uses its private key for its digital signature and encrypts its message with Y's public key. And at the receiver side, the receiver will decrypt the message with its private key and verifies the signature with sender's public key. It's very simple. Sender will have their private key only for the digital signature, and receiver will have the private key only to decode the message. So they should share their public keys. So X uses the private key for digital signature and Y's public key for encrypting the message. And Y will have private key for decrypt the message and uses the X public key for verifying the digital signature. So the operations will happen like on the encryption side, X private key followed by Y's public key. In the decryption side, Y is private key followed by X public key. So answer is option D. It is a very direct and easy question. We have to think in deeply. Next question. In a RSA crypto system, a participant A uses two prime numbers P equal to 13, Q equal to 17 to generate her public and private keys. So using this private number, they are generating the public and private keys. If the public key is 35, what will be the private key? So for this question, we need some equations that you can find in the book directly. And here I am also telling that this is a major equation, that is the public key into private key modulo the first case psi of n should be 1. So here we have the value of public key, we have to find the value of private key. So on putting which number here, we can get the modulo as 1. Modulo psi of 1 as 1. So here psi of 1 is nothing but P minus 1 into Q minus 1. They are using two values for creating the keys now. So we just P minus 1, 13 minus 1 into 17 minus 1. This will be the public and private keys multiplication value. So psi of n is 192. So we just apply all this, and by finding the D value, that means by keeping which value at the place of D, the modulo should be 1. So to calculate this, we just do the calculation here. E star D modulo psi of n is equal to 1. Here apply the values 35 star D modulo 192 is equal to 1. So remodifying this equation, 35 star D is equal to 1 plus 192 star K. Here K might be any of the positive integer value. So we just apply K is equal to 1 here. By applying K is equal to 1 here, what will be getting? 1 plus 192 star 1, that is 1 plus 192. 1 plus answer 193. 35 star D is equal to 193. And to find D, we get 193 divided by 35, we will be getting some decimal value, and modulo will not be 1. So we should have here the modulo should be 1. So that means it should divide with a complete whole integer. So here we cannot get the answer if we keep K equal to 1. Let's put K equal to 2. And putting K equal to 2, 385 divided by 35. So answer D will be 11. It's a whole integer. So also if you keep 11 in this equation, 35 star 11 modulo 192 will be 1. Directly it comes 1. So the answer is 11. Just try to solve this by putting the values. Once you get the value, again we have to check by put the value in this equation, and we should get the value as 1. So the answer is 11. Here we have to keep in mind these two equations for RSA crypto system method. So hope you understand all the solved questions, and please subscribe for more solved gate question papers. Thank you.